today's class, where we are looking at reducing matrices to echelon form, and then we'll use that knowledge to solve a system of linear equations. So we'll begin by definition, where we look at the definition of a matrix that is in echelon form. So we can say that a matrix is in echelon form, or a matrix is not in row echelon form if it fulfills the following properties. So the first property is that the first non-zero entry, which we shall call the leading one, or the leading entry in each non-zero row, is in a column to the right of, no, in a column to the left of the any other leading entries that is called that is below it. So the other leading entries, what I mean is, for instance, if you look at the matrices down here, let me just use that example. If you look at these matrices, you notice that the first matrix, the leading entry in this column, the leading entry is 2. In this other column, now we look at the rows. So the first row, we have this leading entry. And then the second row, we have this leading entry, which is 2 here. In the third row, we have this leading entry, which is 1. So what point 1 means is that in this column, this leading entry is to the left of this other leading entry. And this leading entry 2 is to the left of this other leading entry 1. Now, let's look at the second matrix. In the second matrix, we have the leading entry 1 in this row. And in this other row, the leading entry is 3. So the leading entry is the non-zero entry in every row. So in this row, the non-zero entry, the first non-zero entry is 1. In this other row, the first non-zero entry is 3. So we call it the leading entry. In this other row, the first non-zero entry is 7. So this 7 shall be called the leading entry. This one does not have a non-zero entry, so the whole of it is 0. Now look at this. So the first non-zero entry in the first row is 1. In the second row, the first non-zero entry is 2, so it becomes the leading entry for this row. And this other row, the first non-zero entry is a 3. Now, so you want to notice that all rows consisting entirely of zeros must be at the bottom. So you look at the bottom and you see that all the rows consisting of non-zero entries are there. So like here we have zeros. So in the last row must have zeros or with some 1 non-zero entry there. Now, so what is important in our today's lesson is how to reduce a matrix to echelon form. So if you're given a matrix and you're asked to reduce it to echelon form, what are you supposed to do? So let's look at examples. And I want to look at an example where I'm reducing a matrix to echelon form. Just a minute, let me do this first. Now, so to reduce a matrix to echelon form, this is what we're supposed to do. To reduce a matrix to echelon form, you can do that by interchanging the rows, or you can do that by adding a multiple of a row to another row, or multiplying a row by a zero constant. So if you perform this process, all these 3 points, if you perform all these 3 points, what you will do in the long run is that you will reduce a matrix to echelon form. So let's look at this example. This example says reduce this matrix to echelon form. And let me just repeat the steps. So the step says what we're supposed to do, we're supposed first of all to make this be the only non-zero element in this column. So I make this to be the only non-zero element in this column. I can also do that. I can also try to make this on 1. I can make this on 1, or just use it the way it is as a 2. So let me first of all make it to be 1 in this. I want to make this one to be the leading entry here to be 1. So to make that leading entry to be 1, and I'm supposed to write my steps, I want to make this leading entry be 1. So what I will be doing, I'll take the first row and divide it by 2. The first row and divided by 2. So if the first row is divided by 2, what I get is, so I divide the entire row by 2. So this will be 1, and this divided by 2 will be 0.5. This divided by 2 will be -1. The other rows, I leave them the way they are first of all. So this is 3, this is -3, and this is -1. Then I also leave it the way it is, which is 1, -2, 3. Now, so I just said that once I have this, I want this one to be the only number in the first column. So I use this one to get in this position. This one. So what am I supposed to do there? So let me write my procedure here. So it's always good to write what you're doing. So my procedure is I want to create a 0 in this position. So for me to create a 0 in this position, I can see that I need this 3 minus 3. So 3 minus 3 will give me a 0. So what have I done? What I've done is I've taken row 2, this row 2 minus 3. How do I get that 3? I'm using this one to get that 3. I'm using this one. So I take 3 times that 1. So 3 times 1 will give me a 3. So that 3 must subtract from this 3. Gives me 0 in this position. So that one I did for the entire row. So that's what I've written. I've said that I'll take row 2 minus 3 times row 1. So row 2 times 3 multiplied by row 1. I get a 0 in this position. I write what I get in this position. Then I write what I get in this position. Now, I'll also do something to this to get a 0 here. I only need this entry 1 minus this entry 1. So also I'm doing, I'm taking row 3 minus row 1. Then I need to write what I get. Just pull this one down that I write what I get. Just a minute. Just pull it down. So that's what I've said. I said that I'd have to take row 2 minus 3 multiplied by row 1. So let me see what happens. What happens is 3 minus 2 multiplied by 1 here will give me 3 minus 3, which is 0. That's why you see this 0 in this position. What about here? I have negative 3 minus 3 multiplied by the entry in row 1. The entry in row 1 is 0.5. So when I do this, I get negative 3 minus 3 point, no, this is 1.5. Is 1.5. This product here is 1.5. So negative 1.5 plus this 3, this is what I have, plus this negative 3. So this gives me negative 4.5. And that's what you're seeing here. So I've decided in this example I used fractions, but you can use decimals the way I'm doing here, or you can also use fractions, there's no problem. Now let's do it in this, let's see what you get here. So this, what was this? This step I had said row 1 divided by 2. So row 1 divided by 2 gave me this. You remember that? It was 2 divided by 2, which is 1. 1 divided by 2, which is a half. Negative 2 divided by negative 1, divided by 2, which is negative 1. Then this step, what I did was, I took row 2 minus 3 multiplied by row 1. Then I also took row 3 minus row 1. So this is the step here. So we've just done that. So we've taken 3 minus 3 multiplied by row 1. 1 is 1. So 3 minus 3 multiplied by 1 is 0. Then negative 3 minus 3 multiplied by 0.5 gives us negative 4.5. And then negative 1 minus 3 multiplied by negative 1. So you notice that this is negative 3 times negative 1, which is positive 3. So this positive 3 plus negative 1 gives us positive 2. Now let me come to this other one. I said row 3 minus row 1. So the element in row 3 is 1 minus this 1 gives me 0. The element here is negative 2. So negative 2 minus this a half minus a half will give me 1.5 or 3 over 2. Which one is it? So this minus and this also minus. So it gives me minus 2.5. This is minus 2.5. This is minus 2 minus a half. That gives minus 2.5, which is in fraction is negative 5 out of 2. Then I come to this 3, which is 3 minus 1. 3 minus 1. So this minus and this becomes positive. So that is 3 plus 1, which is 4. Now, so we have this. What is our target? Our target, what we are targeting is that we have the leading one here, and that it becomes the only element, non-zero element in that column 1. After that, we come to the second row here, and we see there's a leading entry here. This leading entry, we can make it 1, or just leave it the way it is. But the thing is, once I have this leading entry, I use this leading entry to create a 0 below it. I use this leading entry to create a 0 below it. And that's what I want to do. What I did in this step is that I made this leading entry to be 1. So to make this leading entry to be 1, what I did was I took row 2, I discovered this, I saw that this leading entry was in row 2. So I take the entire row 2 and multiply it by the negative 2 out of 9. Negative 2 out of 9. So I want this to be 1. What I know is that if I take, let me just erase this first. Or let me get some, let me move it down. Let me move it down first. So what I was saying is, once I have this leading entry in this first column, I've used it to create zeros elsewhere. So I come to this second row and identify the leading entry. The leading entry is here. So I make this leading entry be 1. And how do I make negative 9 out of 2, negative 9 out of 2 be 1? How do I make negative 9 out of 2 be 1? So I can do that by multiplying this by negative 2 out of 9. So I multiply by its reciprocal. So you discover that this will give us 1. This will give us 1. So that's what I did for the entire row. I did that for the entire row. So 0 times negative 2 out of 9 gave me 0. Then negative 9 out of 2 times negative 2 out of 9 gives me 1. What about 2? 2 multiplied by negative 2 out of 9 is what gave me negative 4 out of 9. So that is how I got this negative 4 out of 9. This other row, I leave it the way it is first. I leave it the way it is first. Now, once I have this leading one, I want to use it to create zeros below it. I don't want to affect the elements above it. Just want to use this one to create zeros below it. And that's what I did. So how do I get a 0 here? How do I get a 0 here? I'm using this 1 and this negative 2, negative 5 out of 2. So for me to get a 1 there, what I want is negative 5 out of 2. If I was to add here 5 out of 2, I want a 0 here. So if I was to add this 2, what I have plus 5 out of 2, this will give me 0. So I want to do this, what I've just done. What I've done, I've discovered that I've taken row 2, no, row 3. This one is in row 3. Then I've added to it 5 out of 2 of row 1. I've added 5 out of 2. So 5 out of 2 times this is what gives me this 5 out of 2. So I do that for the entire row. So what I want to do is, I want to write the step here. So the step is row 3. And I said that in your working, it's good to indicate the steps. So row 3 plus 5 out of 2 of row 1 is what I want to do. Now, so row 1 remains where it is. Row 1 is 1, a half, negative 1. Row 2 remains where it is, 0, 1, negative 4 out of 9. But what I want to change is row 3. So the new row 3 must be this. The new row 3 must be row 3 plus 5 out of 2 row 1. So, and I've said that I not touch on elements above row 2. So I only want the elements below row 2. So this negative 5 out of 2 plus negative 5 out of 2 plus 5 out of 2 row 1. But the element in row 1 is 1. So this gives me 0. It's this 0 that I've written here. Now I come to this second, this one now. I come to this. What I need is 4 plus 5 out of 2 row 1. But the element in row 1 is negative 4 out of 9. Negative 4 out of 9. So I add this, and you can use your calculator to do this. What I notice that 2 would go here, negative 2 times. So what we now have is negative 4 minus 10 out of 9. Minus 10 out of 9. So the LCM here is 9. And this will give us negative 36 negative 10, which is negative 46. Yes, I mean, let's look at the signs. Let's look at the signs. This was positive 4, not negative 4. It was positive 4, not negative 4. It was positive 4. So it's positive 4. Suppose it's positive 4. So positive 4 plus 10 out of 9. So this will be positive 36. So positive 36 minus 10 out of 9. That gives us positive 26 out of 9. That's what I have. Positive 26 out of 9. Now, so I have this leading one, which I've created. I have this leading one. I have this leading entry. I may want to make this leading entry be 1. So if I want this leading entry to be 1, so that all my leading entries are 1s. So if I want this leading entry to be 1, then I think of what to do. So I have noticed that what I have there is 26 out of 9. So if I took this 26 out of 9 and multiply by its reciprocal, which is 9 out of 26, I would have 1. I would have 1. Now, so let me look at another example. Let me just look at another different example that we see. So this matrix now is now in echelon form. This matrix in echelon form. So what we're just doing is we create a leading entry here and use this leading entry to create zeros below it. We come to the second row, identify the leading entry and make it 1. Identify the leading entry and make it 1. Once you've made it 1, use it to create a 0 below it. And that process continues until you have a matrix that we have that looks like this. A matrix that looks like the leading entry is 1, then we have 0 below it, then we have another leading entry, we have 0 below it, then we have another leading entry, we have 0 below it, and so on. Let's look at another example, very easy example. So the good thing is that we'll be using this knowledge to solve systems of linear equations. I just want to look at another simple example, so that we use it to another. So let me write some. And the question is, reduce the matrix to echelon form. Reduce the following matrix to echelon form. So what is my matrix? My matrix is 2, 3, 7, 2, 3, 7. And then I want 4, 7, 12. So let me reduce this matrix to Echelon form. So the first thing we said we do, let's create a 1 in this position. So to create a 1 in this position, I want 1, that position, that element is in row 1. So row 1 divided by 2. Row 1 divided by 2, this will give me the entire row 1 divided by 2. That give me 1, 3 out of 2, and 7 out of 2. Now, row 2, we've not touched it, so it remains where it is. We've not touched row 2, so it remains where it is. Now, we've created this leading entry, so we use this leading entry to create to create a 0 below it. Use it to create a 0 below it. So how do we create a 0 in this position? How to create a 0 in this position? So to create a 0 in this position, I need to use this leading entry that I've created. So I take row 2 minus 4 multiplied by row 1. Because I know that a formula by this, formula by 1 subtracted from this 4 shall give me a 0 in this position. So, but I do it for the entire row. So let me write what row 1 is. Row 1 is this. And then I multiply it by 2 and subtract from 2. So 4 times, no, I multiply by 4, multiply by 4 and subtract from 2. So 4 times 1 times, it gives me 4. 4 times 1 gives me 4. So that 4 subtract from this 4 gives me 0. What about 7 minus 4 multiplied by the entry in row 1? This is the entry in row 1. What does this give me? This gives me 14, 14 minus 12 out of 2. I've just written this under the same LCM because this is 12 out of 2. So, and this is like 1 here. So 1 goes into 2 twice. So 2 times that gives me 14. Then minus this 12. And this is the same as 1. This is the same as 1. Because this will be 2 divided by 2, which is 1. And then I do it for this other one. 12 minus 4 multiplied by row 1. The entry in row 1 is 7 out of 2. The entry there is 7 out of 2. So when I do this, the LCM there is 2, and this is 24 minus 28. You know how to do this. You know how to do this because it's 20. This 12 minus 28 out of 7. The fact 28 is just what is it? This is 14. This is 14 out of 2. 28 out of 2 is 14. So this gives us negative 2. This gives us negative 2. So it's negative 2 that I write here. Now, so this matrix is already in echelon form. Because this is the last row, we do not have rows below it. If we would be having rows below this, I would have used this one here to create a 0 below. To create a 0 below this column. But since this is the last row and I have the leading one and I have the leading one, so this matrix is in echelon form the way it is. Let me look at another example. The last example, let me look how to solve systems of equations or using a matrix to echelon. pull this and write my matrix. So the matrix that I want is 4, 1, -1, 4, and then 5, 2, 8, 15, and also want 3, 1, -3, 1. So this is a matrix that I want to reduce to echelon form. So the question is reduce to echelon form. Reduce to echelon form. We also say that we can call it raw echelon form. So reduce to echelon form. Let me change the color of the pen. Okay, so I want to reduce, let me just see the matrix. It's again 4, 1, -4, -1, 4, 4, 1, -1, 4, and then 5, 2, 8, 15, and then 3, 1, -3, 1. So I want to reduce this to echelon form. And again, there are very many ways we can do this. To create, we already have this leading entry, which is 4 here. We already have this 4. So this 4, we want to make it 1. So to make it 1, there are various things we can do. The first thing we've said, we divide this by 4, the entire row by 4. That is one way of creating a 1 in this position. The other way that we can create a 1 in this position, you notice that the third row has a 3. So if this 3 was to be subtracted from this 4, I'd be having a 1 in this position. So I can achieve to get a 1 in this position by either dividing this row by 4 or subtracting row 3 from row 1. When I subtract row 3 from row 1, you notice that this 4 minus this 1 will give me a 1. But let's use the method that we've used before. The method we've used before was row 1 divided by 4. Row 1 divided by 4. So what do you get? So 4 divided by 4 is 1. 1 divided by 4 will be a quarter. -1 divided by 4 will be -1 out of 4. And then 4 divided by 1 will be 1. These other rows will not touch them, so we just write them here. So I hope that this example now, by this example, we'll understand how to reduce a matrix to echelon form, and then we use that knowledge to solve system of linear equations. Now I have this leading entry 1. I now use it to create zeros below it. How do I create a 0 here? So to create a 0 where there is 5, what I'm doing is I'm taking 5 is in row 2, and then subtract 5 times row 1. 5 times row 1. I also want a 0 where there's a 3, and 3 is in row 3. So I have row 3. And to get a 0 in this position, I need to multiply 3 by this one. So 3 by row 1. So this difference will give me a 0. Let me do the first one. So the first row, remember, it is 1, a quarter, negative a quarter, and then 1. row 2 minus 5 row 1. So 5 minus 5 multiplied by this gives me 0. Just a minute, let me. Okay, so we've already done 5 minus 5 multiplied by the element in row 1. We are using this. I've said that we have to write what we are doing. So I've written what I'm doing. So 5 minus 5 multiplied by the element in row 1 is 0. 2, let me just do it here, the rest. 2 minus 5 multiplied by the element in row 1. The element in row 1 is a quarter. So what I get here, the LCM is 4. This is 8 here, minus 5. 8 minus 5. Just unshare this and then share it because I can see it's not writing clearly. Let me just unshare it and then share again. I'm just share and share so you can write. Close it first, then open. Because I mentioned shade under the views comments and respond to it. So if you have any question or comment, you can just write under the views. I'll be able to respond to your question. And if you're not subscribed, you can also subscribe. When I video it immediately. I'm checking it just to see if there is any question so that I can respond to it. Okay, so let's continue. Let's continue with the now write clearly. Now, so let's just go back to what we're doing. And what I said is we were working out this one, and we just said that LCM is 4, and that we have a 1 here. So 1 goes into 4 times. 4 times this gives me 8, and this is -5. So when I do this, I get 3 out of 4. So this 3 out of 4 is what I write here. 3 out of 4. I do it also for this other row. I have 8 here minus 5 multiplied by the element in row 1. The element in row 1 above 8 is negative, a quarter. The LCM here is 4, and 4 times 8 give me 32. And this is negative 5 times negative 1, which is positive 5. So this gives me 37 out of 4. And it's what I write here. So it's very good when you're doing this, it's very good to take good use, take a very good look at the signs so that we do not confuse the signs. Remember, it was 8 minus 5 multiplied by negative this. Now let's come to the last element. There, it's 15 minus 5 multiplied by the element in row 1, which is 1. And this is 10. Now come to the last row, and we've said that we take row 3 minus 3 multiplied by row 1, because our main aim is to have a 0 here. And whatever we do to obtain a 0 in this position, we do it for the entire row. So 3 minus 3 multiplied by 1 gives us 0. Then we come, this is 1 minus 3 multiplied by the element in the first row is a quarter, and the LCM here is 4, and this is 4 multiplied by, no, minus 3. 4 minus 3, so that gives us a quarter. What about this? So it's 1 minus 3 multiplied by the element in row 1, which is negative a quarter. So this gives us the LCM there is 4, and this will be 4 minus, it's not minus because this minus times minus, that will be positive 3. So this is 7 out of 4. Seven out of 4. What about this? It will be 1 minus 3 multiplied by the element in row 1, and the element in row 1 is 1. So this gives us negative 2. We've achieved our first mission. Our first was to put 1 in that position and use that 1 to get zeros elsewhere in the and so the next thing we will do is to draw, identify and delete 1. The leading one, let me just erase this first of all, so I use it. Erase this place. We use it for the next step. So when you look at the second row, you realize that the leading entry there is 3 out of 4. So that 3 out of 4, we want to make it 1. And once we made it 1, we use it to create zeros below it. So that is what we want to do, and those are the steps. So after erasing this, we do that. And then after that example, we look at now how to solve system of linear equations by Gaussian elimination. Because Gaussian elimination is a method that we're using, reducing a matrix to echelon form. So we reduce a matrix to echelon form, and then after that, we solve that system of linear equations. So as I said, that if you have a question, supposing there's a place you do not see how it has been done, you can write your question under the posts, and I'll be able to see it. And I'll explain it, even if not today, and then later I have to explain it. Now, so I want this entry to be 1. So what are we supposed to do in this situation? So to create this entry to be 1, I want to multiply it by its reciprocal. So row 2, and I'm doing it to the entire row 2 times 4 out of 3. So I'm not touched row 1, so row 1 remains where it is. Row 1 remains where it is. I'm only interested with the row 2 this time. So it's row 2 that I'm multiplying by 4 out of 3. So this times 4 out of 3 gives me 1. This times 4 out of 3 gives me that 7 out of 3. That's 7 out of 3 because I've just taken that 7 out of 4 and multiplied by 4 out of 3. So that 4 in the numerator cancels the 1 in the denominator. So I'm left with that 7 out of 3. I'm also multiply this one by 4 out of 3, and what I get is 40 out of 3. I've not touched row 3, so it remains where it is. Row 3 remains where it is. 7 out of 4. And this is -2. I've created a leading one in row 2. I use this leading one to create a 0 in this position. And whatever I do it for the entire row. So let me do that. So I have row 3. And if I want a 0 in this position, I have to take this a quarter minus a quarter. So how do I get the second a quarter? So it's minus row, no, this is row 3. Row 3 minus a quarter of row 2. Row 3 minus a quarter of row 2. So let's write what we get. The first row is untouched, so we just write where it is. Just write it here. And then 1. The second row, we just write the way it is. And it's always very good to be careful because once you do something wrong, it affects the entire working. Now, so we are multiplying a quarter by row 2. And then subtracting the result from row 3. So this by a quarter is 0. From this gives me 0. This by a quarter, I get a quarter. From this, I get 0. This by a quarter, what do I get? I get that 7 out of 12. I get that 7 out of 12. That's 7 out of 12. So this 37 out of 12, I subtract from 7 out of 4. And then same is 12. This is 12. So do this. 4 goes into 12 3 times. 3 times this gives me 21. 12 goes into itself once. 1 times this gives me the 7. What is this subtraction here? Is it negative 16 out of 12? You just write it without even simplifying. Negative 16 out of 12. Let me just be careful that I'm not writing a different thing. Yeah, it's negative 16 out of 12. And let me come to the last one here. It is negative 2. Just do it here. Negative 2. I'm looking at the operation here. Minus A quarter multiplied by this. What is a quarter multiplied by this? Is 10 out of 3. It's 10 out of 3. And you can use your calculator here. The LCM is 3. The LCM is 3. So this would be negative 6 minus 10 out of 3. So this becomes negative 16 out of 3. Negative 16 out of 3. Now, so we have the leading entry here, which is 1. The leading entry is 1. The leading entry here is negative 16 out of 12. Negative 16 out of 12. So we can also make it 1. And so how do you make it 1? You can make it 1 by multiplying the entire row by the reciprocal of this 16 out of 12. Let me just do that. So what I'm saying is I take row 3 times negative 12 out of 16. Negative 12 out of 16. So let me create this for how to solve system of linear equations, and we continue that in our next lesson. So I just want to show you. Let me share this. Then create some. Property. Okay, so share it again. So some is now okay. It's now okay. So now, so we just was multiplied by the reciprocal of negative 16 out of 12, and let's just do that. Let me just write the result here. Result here. So row 1, remember it is, which is 1 a quarter, negative a quarter, 1. Row 2, remember it is, which is 0, 1, 37 out of 3, and 40 out of 3. And now it's this row 3 that we multiply by negative 12 out of 16. So this times negative 12 out of 16, you get 0. 0 times negative 12 out of 16, you get 0. What about this? Times negative 12 out of 16, you would have a 1. And this one, the last one is negative 16 out of 3. Multiply this by negative 12 out of 16. And you know that the 16 in the denominator cancels the one in the numerator. And this one goes there 4 times. Goes there 4 times. Goes there 4 times. Yeah, I think that is what it is. What is it? This is 16 and that is 16 cancels. And then this one goes there 4 times. Minus times minus is positive. So this is a matrix in echelon form. So this matrix here is in echelon form. Now let's solve system of linear equations using Gaussian elimination. So I just do one example and we continue with the other examples next time. Just and share this. A blank page. So the purpose by Gaussian elimination is to use a math form and then you solve that system. And that's what I will do. So let me just share place to do that. Just a minute. Talk is slow, but Gaussian elimination. So this is a method that we use to solve system of linear equations by first of all writing the augmented matrix. So let me say solve my pen as a problem. Solve this 2x plus 3y is equals to 7 and 4x plus 7y is equals to 12. So this simultaneous equation, this is a system of linear equation. Because we have a linear equation and another linear equation. So once you have several linear equations put together, we call it a system of linear equations. So to solve this, the first thing we do is to write the augmented matrix. Augmented matrix. And then reduce that augmented matrix to echelon form. So the augmented matrix just extract the coefficients, and this is 2, this is 2, 3, 7, and this is 4. Now, this augmented matrix. So this is the augmented matrix as I've said. So I just extract the matrix, the coefficients here, and it's 2, 3, 7, 4, 7, 12, and then reduce to this to Echelon Form. So I know what I need to do. I need to divide the row 1 by 2. We've just done this. So dividing by 2 there, I have 1, then I have a half, then I have 7 out of 2. And then this other row, I've not touched it. Once I have this leading one, I use it to create a 0 in this position. So, and we know what we're supposed to do. We're supposed to take row 2 minus 4 row 1. So row 2 minus 4. So row 1, we will not touch it, so we just leave it where it is. This is 7 out of 2. Now, so 4 minus 4 multiplied by this gives us 0. And then 7 minus 4 multiplied by this. So 4 multiplied by this would be 2. So this gives us 5. And this 12 minus 4 multiplied by 7 out of 2. In fact, this is 14. This is 14. So 12 minus 14, that is negative 2. So just a minute. Just a minute. Just a minute.